Hi everyone, Mr. Rodriguez here with another video for you guys. Today we are going to be talking about arcs and arc length in circles. So let's start by doing some general notes on this subject. So the first thing I want to talk about is what an arc is. So an arc is basically just sort of like a part of the circumference of the circle. Like, say that would be an arc, right? This would be another arc over here. It's basically just a part of the perimeter of the circle. So arc length simply is the measure of an arc of the circle. So we can write that down. The measure of an arc of a circle. So it's just a regular measurement. It could be in feet, inches, centimeters, whatever. And one thing we might notice about an arc is, let's say we kind of create, let's say we have our center point here, and let's say we kind of make an angle here. So do you see how you have this angle here, and you see how kind of like the angle intersects with the circumference here and here? So you see how it kind of creates this specific arc and this specific arc length. So there's actually a relationship between the measure of the arcs and the central angles. That's what this angle here is called, the central angle. A central angle, we can define over here, is an angle made by two radii that intersect at the center. Right? You see how this is a radius over here, this is another radius over here. So you have these central angles that are formed by two radii that intersect at the center point. And again, you notice that they create this this arc length over here, right? So let's look at some more definitions here. Next on the list, we have something that will come up is a chord. I have defined this before in class. A chord is just any line segment on a circle that touches 2 points on the circumference but does not intersect the center point. So it's basically just any kind of line that is not or any line segment within the circle that's not a diameter. So let's say a chord is just a line segment that intersects two points on the circumference. So we'll just leave it at that. And next thing I want to talk about, the last definition here, is something called an inscribed angle. So you see how I made this angle over here right, in the center. Well, I could also make an angle with two chords. So here I made it with two radii, but I could also make it with two chords. So we see we already have one chord over here, and you see what happens if I just make another chord, kind of like that. See how it forms another angle? And again, it forms another arc length, right? So an inscribed angle is just an angle made by two chords that intersect at their endpoints. Okay, so that's the basic vocab you'll need for this lesson. So now we want to talk about actually calculating the arc length. So again, here I told you arc length is just the measure of, one of these kind of curves, and you have these angles, right, that are kind of formed that can form an arc length. And there's actually a relationship between the angles and the arc lengths. So first, just a little review thing. If you remember, the formula for circumference of a circle is pi times the diameter, right? And the diameter, if you remember, is just 2 times the radius, right? So another way to write it would be pi times 2r. Or usually you'll see it as 2 pi r. Same thing, just it's a better mathematical way to write it. So our circumference is 2 pi r. So basically what you can do is, let's take a look at another sort of. So when you have, say, a central angle, so let's say something like this. Oops. So let's say that this is 60 degrees here. Do you remember how the degrees of a circle is 360 degrees? So if you think about it, that means the degrees all around the center point is 360 degrees, right? So, and then this angle here is 60 degrees in this example. So you can kind of say it's like 60 out of 360, right? You can set up a little proportion here. So you could say, right, that you have 60 out of 360. So that would be the same thing as 1/6, right? And the way you can find arc length here is, if you think about it, if this angle here is 1/6 of the total degrees of the circle, then this arc length over here must be 1/6 the circumference of the circle. So basically, the way you can write out a kind of general formula is, so this is going to be a more general formula. So we have the arc length, we'll use that as AL, I guess, arc length equals, and then it's whatever you want to call this angle there. Let's just say I make a little symbol for that, or let's just say I call it x degrees out of 360 degrees, right? So I'll basically give you kind of like a percentage. And then times, and again, we said it's just a circumference, right? So again, we use this formula, 2 pi r. So this is basically a general formula you can use. You could say arc length is equal to, so the length of this over here is going to be equal to, as long as you have a central angle, it's going to be the degrees of the central angle, over 360 degrees, times 2 times pi times whatever the radius is. So let's, for this example, let's just say radius is 7. You would plug a 7 in there for radius. So you have everything. You would plug all this in, and you will get a specific number, right? So that is for, keep in mind that's for a central angle when it looks like this. Now let's say, look at arc length from an inscribed angle. Remember, inscribed angle was when, again, if I scroll back up, it looks something like this with two chords, right, intersect at a point and form an angle over there, right? So one thing you might kind of notice is, this is a good way to kind of look at this. So in our drawing over here, right, we said we have this central angle that intersects right at those 2 points. What if I made another angle that intersected at these points again, but actually started all the way like somewhere over here? So let's take kind of a look. Let's say I could make something like this. So let's say we have an angle here. Now, just visually, if you think about it, is this angle here or this angle over here, are they the same or are they different? They're different sizes, right? This angle that's back here is going to be smaller than the angle that's closer, right, to the arc. And one thing we can basically know is that it will be this angle here. Let me use my highlighter. This angle over here will be half this angle over here. So it's always something you can use. So if I gave you the central angle over here, you know that this angle is half, right? And on the other hand, if I give you this angle in the left there, you know that the central angle is double it, right? So then let's think about kind of what a general formula for inscribed angles would be. Again, this one is an inscribed angle, right? So an inscribed angle, it's really going to be a similar kind of thing. We basically use the same formula that we used before. We're going to use this again. The only thing is just that we need to get this this x, right? If we're given an inscribed angle, we don't just plug that in and put it over 360, right? That's only for central angles, right? So basically, all you want to do is, let's go back. So let's just say I call this angle y over here, right? Let's just say that's y. Basically, all you need to know is that arc length would be equal to 2 times y, or y degrees, over 360 times 2 pi r. So you see that? You basically just have to know, it's almost like the radius diameter thing we talked about, just knowing when you can just use the number outright or when you have to double it or half it. So just pay attention to that. All right, so let's take a little look at an example here. So our example says, what is the length of the arc of degree that measures 60 degrees in a circle of radius 10 centimeters? So we're basically, for this problem, it's worded a little weirdly, but what this arc of degree, what this little thing basically means is it's just saying what is the measure of the arc. So this purple right over here is the arc, and it's saying what is the measure of that arc if the angle is 60 degrees. So they didn't draw the angle for us, but we can draw it ourselves. Kind of looks something like that. Oops. Right. So we have a 60 degrees. So it says 60 degrees here, so that means we know this is 60 degrees over here. And it tells us that the radius is 10 centimeters, right? That's also labeled over there. The radius is 10 centimeters. So, again, all we have to do is just use our trusty formula. So the first thing to notice is this a central angle we're given here, or is this an inscribed angle? Since it's formed by two radii, it is a central angle. So we could just use our formula, and we have arc length equals, I'll write out the general formula first. We can say, again, since it's the central angle, we can just say x degrees over 360 degrees times 2 pi r. And now we can plug everything in that we need. So our x is just 60 degrees, right? Over 360 degrees times 2 times pi, and then times our radius is 10. All right, so let's simplify this a bit. So AL equals 60 over 360. We said that is just 1/6, right? The degrees you can think kind of cancel out. And then we have times 2. Well, actually, you know what? Let's be smart. Let's say 2 times 10 is 20, right? 20, and then we can just leave the pi. And then our final answer could be 20 over 6 pi. If you want to simplify that further, you can have 10 over 3 pi. So, and again, you can decide whether you just want to leave the pi or if you want to change that to 3.14 or something and do the calculations, but this is fine. So there you have it. So we know what arc length is now, we know how it relates to the angle, and we know how to calculate arc length given the angle. And of course, if you're given arc length, you can also use it to calculate things like the radius or the degrees of the angle, right? It's just you just plug in what you have and solve for what you don't. All right, that is it for the notes. So now you can work on some, I think you have 6 independent practice problems here. Good luck and have a great week.